In this video, we're going to talk about composition of functions. The expression that you see here, written like this, is read f of g of x and literally means f of g of x. It means that we use the output of the function g as the input of the function f. So for instance, suppose that we have f of x equals 2x minus 1 and g of x equals the square root of x. Well, when we see f of x equals 2x minus 1, what that really means is f of block equals 2 block minus 1. Well, if they want us to find f of g of x, then they're telling us to put g at x in for that block. So we simply put g at x in for that block. But what is g at x? G at x, as you see here, is the square root of x. So using that philosophy, we see that f of g of x, which we can rewrite as f of g of x, is equal to 2 root x minus 1. On the other hand, how about g of f of x? Well, when we see that g of x is equal to the square root of x, where I've put the two arrows there, what that really means is g at block equals the square root of block. Well, if I'm asked for g of f of x, then what they're really saying is put an f of x in for the block. So I put it in for the block here too. But what is f of x? F of x is 2x minus 1. So instead of saying root f of x, we're really saying root 2x minus 1. And we can rewrite it as g of f of x. And so we see f of g of x and g of f of x have some similarities in the way they look, but they're actually different functions. And that's what we're showing here. Okay, we've got an expression for f of g of x, and we have an expression for g of f of x. Now, imagine we then want to evaluate f of g of 25 and g of f of 25. We're going to look at two different methods for doing this. We have method 1. Since we have a formula, literally on the last page, we were given this formula here, 2 root x minus 1. So since we know that f of g of x is 2 root x minus 1, then obviously f of g of 25 will just be 2 root 25 minus 1. That's pretty quick. Pretty quick solution. The square root of 25 is 5, so it's really just 2 times 5 minus 1. Ultimately, it's 9. And again, on the previous page, we had this where I'm drawing the arrow, square root of 2x minus 1. That's what g of f of x is. So I can write that up at the top. G of f of x is the square root of 2x minus 1. So by looking at what I've circled in the top right, if I'm asked for g of f of 25, that's just the square root of 2 times 25 minus 1. Well, that's root of 50 minus 1, which is root 49, which is 7. So we have a value for f of g of 25, a value for g of f of 25, and note that they're not necessarily equal to each other. Okay? Now, that method, what I called method 1, that's useful when we actually have an expression for both f of g of x and g of f of x. We have those expressions because we were literally asked for them in part A. It is possible, though, to answer this question without actually having an expression for them first. How we would do that, if I'm looking for f of g of 25, that's like saying what is f at g at 25? So one way to do it is just evaluate g at 25. What's it equal? And once you find the number, plug it in for f. And similar, so to find f at g at 25, we simply find g at 25, it's equal to 5. And then instead of saying f of g of 25, we say f at 5, right there. So f at g at 25 is the same as f at 5, because we just showed g at 25 is 5, and we evaluate it to be 9. Method 2 is actually a little quicker if you don't actually have to find an expression for the expressions themselves in terms of x. You can actually just cut right to it by using calculations. If that didn't quite make sense, let's do the next one. For the next one, we wanted to find g of f of 25, so that means we're looking for g of f of 25. When you get a question like this, work from the inside out. So we'll find out what f at 25 equals. So since f at x is 2x minus 1, then f at 25 is 2 times 25 minus 1, which is 49. So instead of saying g of f of 25, we can say g at 49. And that's what we have here. And since g at x is root x, g at 49 is root 49, which is 7. We get the same answers, and we cut to them a little bit more quickly than in the previous question, than in the method 1. Now, for this next one, suppose the functions f and g are given as shown, and we want to determine the values f of g of 7, g of f of 4, f of g of negative 3, and f of 9. Let's do part A. We'll do f of g of 7. F of g of 7 actually means f of g of 7. We're going to work from the inside out. We're going to find out what g at 7 equals. So what we do is we look at the function g. G at 7 is the y coordinate that you get when the x coordinate is 7. So we look at this one right here. The y coordinate we get when the x coordinate is 7 is 9. In other words, g at 7 equals 9. So instead of saying f of g of 7, we'll say f of 9. Now, what is f of 9? Well, we look at the f function, and we ask ourselves, what is the y coordinate when the x coordinate is 9? And the answer is negative 3. So the final answer to part A is negative 3. And there's our answer. So let's do the next couple of questions here. G of f of 4. Okay, so g of f of 4 means g of f at 4. F at 4 is negative 11. So we can say g at negative 11. G at negative 11 is 5, because in the function g, when x is negative 11, y is 5. All right, now let's try f of g of negative 3. Well, we look in the g function. In the g function, when x is negative 3, y is 6. So f of g of negative 3 is the same as f of 6. So this is what we get, f of 6. But then we look to see, well, what is f of 6? To find f of 6, we look in the f function, and we ask ourselves, what does y equal when x is 6? And then we realize, gosh, x never equals 6. X is only negative 3, 0, 4, and 9. If x is negative 6 in the if x is never 6 in the f function, then f of 6 doesn't exist. And finally, f of 9. So what we do is we look in the f function for when x is 9, and we see that y is negative 3. So instead of writing f of 9, we can write f of negative 3. And then we look again in the f function. We didn't even need g for this one at all. We look in the f function and we say when x is negative 3, what's y? And the answer is 2. All right, let's do this next question here. We have f of g of 4. To find f of g of 4, what we can do is first of all find out what does g at 4 equal. Well, g at 4 is equal to negative 1, because in the g function, when x is 4, y is negative 1. So for part A, f of g of 4, that's the same as f of g of 4. I'm going to work from the inside out. We find out what g at 4 is, which we just said a minute ago is negative 1. So we have f of negative 1. To find out what that is, we go back to the f function. We go to an x value of negative 1. We see that the y value there is 3. And so our final answer for part A is 3. And there's the explanation of it. Same explanation we gave a minute ago. Okay, let's do a couple more of these questions. For part B, We're looking for g of f of -1, so that's the same as g of f of -1. We work from the inside out. We'll find out what f at -1 equals. F at -1 is 3. Then we go to the g function. We let x equal 3, and we figure out what y equals, and the answer is -4. And there's the strategy. Okay. For part C, we're looking for g of f of 1. So I like to just write it out this way first sometimes. G of f of 1 is the same as g of f of 1. Let's find out what f at 1 equals. Since the point 1,5 is on f, that means f of 1 is 5. So instead of g of f of 1, we'll call it g at 5. Okay, so that's what we have here. G of f of 1 is the same as g at 5. That means we look to on the g function for an x-coordinate of 5. Well, an x-coordinate of 5 is way out here, but this function doesn't go that far to the right. And so it does not exist. And finally, g at 3. That's the same as g at 3. So we let x be 3 on g, and when x is 3 on g, y is -4. So instead of saying g at 3, we say g at -4, and that's what we have written here. And now we go to where the x value is -4 on the g function, and we realize, you know what? It never goes that far over, so it does not exist.